Hello everybody, thank you, thanks for the introduction. So I have been building tools for quite some time now, around 12-15 years within Bosch, classic AUTOSAR, adaptive AUTOSAR, and I can say that with this new SDV topics coming in, the tool landscape has really exploded, and I would like to congratulate AUTOSAR also for this, for bringing in so many new partnerships like Ecosystyem, SDV, into the picture, which has made tool developers and even our embedded developers much more interesting. So in my talk, I will be focusing on what kinds of tools we have started delivering as of now, or what we do to build a tool ecosystem. Because there are so many challenges on interoperability that we have faced, and coming up with ways what we need to do even for that. So I will touch upon those topics. Okay, so let's start. So this is generally the promise of SDV. There are too many functionalities or goals or promises that are there for SDV. First is we need to look at safety in a much more way. So driver assistance, all this collision, anti-collision systems, and as they have become a major part of improved safety of the vehicle. Then increased comfort, onboard infotainment systems. We need to look at the convenience features which are coming into it. Yeah. And also for deeper insights through telematics and diagnostics. So these are also some parts of SDV. So there can be many apps which could be rewritten for SDV in these areas. Yeah. So major point I want to make is if you see the applications which are being talked about. So 80 to 90% of the applications are being redeveloped for these areas. So we need newer tools, new approaches of developing these applications, and majorly for that we need data platforms. Yeah? So these data platforms and vehicle software platforms are on which these tools would or these apps would work. Right? So I'll just go deeper into it. So this was just one of the VCG market model possibility. They had said that this application market is really going to boom over the couple of years. Yeah? But to make it happen, the data platform within the vehicle, we need to really make it accessible to the embedded developers. Yeah? So the challenges really go up when you really have to talk about vehicle applications. Do we have integrated data platform for our application development? For example, if any of us want to write an SDV app, can it be really portable? Can it really run on different variants of the car? Can it really be taken on from one OEM to another OEM? Is it really possible? So interoperability is a big challenge because most of the data which is there inside the car is highly proprietary. There are signals which are highly proprietary, apps cannot be ported easily, and the data models are also varied, the signal models, etc. So and also the vehicle software platform is highly proprietary. Yeah? There are variants in ASIL levels. For example, this stack provider says there will be ASIL B, the other stack would say I'm ASIL A, etc. So there will be a lot of variance in the stacks itself, which leads to higher challenges when we try to build vehicle applications. So interoperability is really the key here. So what we really require to write proper apps, SDV apps, is a shift to interoperable service-oriented architectures. Yeah? So this is something which is completely changing. We need interoperability, so definitely service-oriented architectures were there. But now in the vehicle, we need to have interoperability within them so that apps can easily access data, and the embedded developer's life is much more easier. So because being a toolie, I have been looking at challenges the developers face, and to make tools appropriate so that it is easier for them to write apps. Yeah? By apps, I mean, I'm not just talking about classic apps, I'm talking about a new class of apps for SDV. Yeah? So these can be looked upon in the digital auto space, where you could have newer experiences in vehicles. Yeah? So you need to have these kind of apps are completely different. Yeah? They're not just the classic AUTOSAR apps or some adaptive AUTOSAR apps. They are a much higher level where you need to work with. Yeah. So this figure is something a bit complicated, but it is one of the building blocks of of service-oriented architecture for SDV. Yeah. So below you could see here, this is the physical, our real-time physical systems, which we have been developing for quite some time for automotive. And these are zone control ECUs, etc., CAN buses, zone control ECUs here, and different actuators and sensors at different points of the car itself. And if you go a bit above, you are slowly going into a digital area now. Yeah? Here you have onboard QM environment and a functional safety layer. Yeah? So this is where the apps are being a bit written, and there's another layer above, which is vehicle to cloud APIs, where you have some apps being written now directly on the cloud. Yeah. So this can be broadly, you can take this as a building block or a service-oriented architecture for software development. So if you take into this, then we have to see what all signal to service layers are there, what kind of vehicle to cloud APIs are there, what is the meaning of these layers in between. Yeah? These become very important because the apps being run here require data which is coming from here. Yeah? So, and functional safety environment is also really necessary because you cannot actuate or just read from any signal which you want without having some safety implications. So that's where this functional safety layer is there, this yellow part, which is going to make sure that the accesses and the actuation is safe for the app. Yeah. So this was about how the service-oriented architecture is there, and this block is really showing us now why we need vehicle APIs. Yeah. So because the vehicle API itself, so you would have heard about talks yesterday on how AUTOSAR and Kosuru are collaborating to build up this vehicle API layer between the green block and the red, which we saw. Yeah. So the idea is here to have a data layer, which I talked about in the previous slides, much more abstracted. So you can talk about it like a vehicle abstraction layer. Yeah. So this vehicle API layer is going to convert some of the classic signals onto a VSS spec. So when I say VSS is something coming from Kosuru. So this is a vehicle signal specification, and we are converting multiple signals, one signal or multiple signals into particular data points, which are looking like a tree model. Yeah. So what is the advantage? Why are we doing this? Because this is a shared abstraction over all the data that is on car. So Kosuru brings us this kind of an advantage. And this is the partnership that AUTOSAR is building with Kosuru, so that we could open up and write applications in a much more simple, easier way and access vehicle data with this. Yeah. So I will explain slightly about this, so maybe not everyone knows. So in this tree kind of structure, you could just add for a particular vehicle, add chassis, etc. And you could add signals. Each of these points is a signal. Yeah. And you could map actual signal data to this data point. Yeah? And finally, when you want to access, you can just say vehicle.chassis.axle.row.wheel. And so that will give you the actual data for it. So it's a very semantic language. Yeah? You just need to traverse and tell that I need for a vehicle, I need for this body, and this is the door. I need the signal value of this. Yeah? So it becomes much more easier for the embedded developer to start writing or accessing data from the app. Yeah. So each of these points is again represented like this. For example, drivetrain, transmission.speed, and what is it? Type is a sensor, and this is the data type that comes up with it, and this is the unit. Yeah. And a description. So each of these points are described in a spec by Kosuru, and they are given out. Yeah. So with this, we would be able to have a common data layer which would be utilized for writing applications, right? And of course, yeah, the functional safety part also comes in the ISO 362 the layer, the vehicle API layer itself will be enabled with functional safety so that the access and the rights to Kosuru VSS is protected. So yeah, here I'm just going to briefly talk about how you could extend VSS models. So you can see here. Like you can see a bit if an OEM wants to add other signals, yeah, so they can add a overlay, like a door is locked and open. So some VSS points would end here, and you could add new branches to it and extend the vehicle signal specification. So there are ways in which you could do this. And this really helps because you can take any base OVS spec and extend it to any new car model that you're trying to make. So this is really helpful in defining much more complex signals that are there. So currently what is happening is every car manufacturer has its own CAN matrix. Every variant may have a different CAN matrix. So this makes it highly difficult for us to really write apps or bring it up to compatibility to other apps that you're writing. So with this, you would be able to really look at all the signals of the car, all the communication within the car with a very simple format, which is the VSS spec. Right? So the idea behind this is, Koyesa came up with this, and AUTOSAR also wants to integrate a bit, and the point of integration is the vehicle. So the Koyesa, they didn't really intentionally want to make this, but they have a goal of constant evolution of digital experiences in and around the vehicle, integrate vehicles into a larger mobility ecosystem of solutions and services. So it's not only about the car that you're driving, it's also about the exposing the signal data which is there on the car to other platforms like V2X, V2 Cloud, V2V. So all of these, for doing all of this kind of a VSS spec is really, really helpful. And that's where you see a partnership between AUTOSAR and Koyesa. So moving on, so that's where beginning of middle of last year we started looking into how we build such kind of APIs using VSS. How do we bring up different signals and map it onto VSS data points? So we were looking into, and there were constant discussions with AUTOSAR consortium how we need to do that. So we got this initial framework where the collaboration case we could make it to reality. So what you could see here is Koyesa brings in its own standard data catalog, so which is all the data points, the full data points of the set, which is common. And AUTOSAR really strong at methodology, tooling, in-vehicle data, and service specification. So these areas AUTOSAR is very strong at. So AUTOSAR will bring in a methodology on how to really write or access vehicle APIs. So this AUTOSAR will. Then it was a consortium, but there was another collaboration with W3C, which is majorly an internet consortium. And they are talking about how to take the data out of the car using certain vehicle to cloud APIs, which we saw as an upper layer. So these all things were getting combined by the end of the last year, and we could see that the AUTOSAR adaptive applications are able to access cloud apps using Koyesa VSS data and get the data, push data, take it from the microcontroller and put it on the top. So this is where adaptive AUTOSAR plays a great role as a mediator or as a broker, where you have a gateway written and you can take data from the classic AUTOSAR, convert it onto as a gateway onto standard data catalog of Koyesa and push it to cloud apps. So this is one way. So we were working on this, alright, and finally we got on to a part where the vehicle API would be realized by a software gateway based on AUTOSAR adapter and coding. So this was, we did a small prototype on this, how to translate signals. We had to make tooling around it. So we really need to look at tools also in a very different context, because in my experience of AUTOSAR tooling, majorly we work with AUTOSAR XML, AR-XML. Now we were working with VSpec, and YAML files. So there was so much diverse tooling coming from the Koyesa side, which was a clash with what we were generally doing. So basically the ideas which were clashing were this. We have a model-based system on the classic or adaptive, even on the adapter. We have a model-centered approach. We have AR-XML, and we try to have a model and we validate the model. But on the newer side, on the Koyesa side, or on the cloud side, what we could see is that there is a API contract. There is a code-centric approach. So code-centric is we need API, and the API works, it doesn't work. Yeah, so that's it. But here, this being more real time, here we had very strict checks on the model, AUTOSAR specs, etc. But here it was code first. So this for tooling is a big break. Yeah, how do you build tools? There is no such validation here. What if something happens on runtime? Yeah, so these were real challenges. Yeah, so on how to address this. So we again looked at the basic structure of how it would be, the zone controllers, etc. We were building vehicle API here. This is called the signal to service, the vehicle API which we are going to build. And we were saying all of this is what is our model centric in AIXML. And here, VSS, this is VSpec, YAML, proto files, all these different kind of files were coming at this level. Yeah. So we had to make AIXML interoperable, all of these things interoperable to make this signal to service API reality. So how did we do that? First of all, we have some tooling already for AUTOSAR adapter called Isolar VRT, which uses, like somebody also in the morning suggested, Franca, a derivative of Franca called Turtle. So we have a language where we could write signals, services, and we had to extend that a bit, yeah, for Cohesive. Yeah. So this is general tooling of Isolar VRT, which we used for RTA VRT. But what we did really was we had to take a Cohesive data point, and this is how you could map signals to it, and even events, and provide a transformation type, instance ID, all of this. So this is where you see a bridge between the AUTOSAR worlds and a Cohesive world. So our tooling also had to evolve in such a way where we are reading these specs and we are building tools accordingly, which are taking IDLs and respecs and providing some kind of a glue code. Yeah. So this was the first step in how we realized vehicle API. So this kind of a mapping was required so that you could map the lower layers to a Cohesive data point and gives you a vehicle API glue code. Yeah. So all of this parts was done, and we presented this in IA Munich last year, where this was the architecture. These were the basic building blocks. The mapping file. The mapping file is the mapping file which you get after you connect Cohesive data points and signals, and the VRT tools itself, which generates proxy skeletons or the ARA provider and actuator, different code generators which were earlier code generators we used to work only on the XML model, but now they are working on VSpec, etc. also based on this mapping. Yeah? And then there's the data grouper. So we used AUTOSAR in the first step. So here, this data grouper is what is really translating at runtime signal data as a vehicle API Cohesive VSS data point. So this part here is what where the magic is, where with gRPC you were able to make this as a gateway to other APIs. So any app need not bother about signal data. They can just call Aracom APIs with the VSS, which is body or chassis or something. And this is a very huge help for embedded developers, because they need not really worry about the bottom layers. They can just put a Cohesive data point and an Aracom call, which will give you the actual vehicle live data. Yeah. So this was the first POC that we had done, and we showed it in a minute. And also now it is further getting developed. We are improving the functional safety part, where this VISS V2 is the replacement. And this also is a AUTOSAR concept 703 called the vehicle API concept, automotive API concept. Yeah, so this is evolving, and we are seeing this come out in the specs also. And VISS is one more W3C compliant, a standard, which is Vehicle Information Service Specification. So this is standard in the Cohesive world, where you could just take up any Cohesive data point using VISS. So we are also moving in that direction. The point I wanted to stress is how you could make AUTOSAR compliant with other frameworks out there, and you could really help in the evolution of SDVs, and how you could really make the tools work with it. because of the approaches which were very different, we had to really relook at how we do it and come up to this kind of a area. Yeah, and also we had to prototype a lot. Yeah, so where do we prototype? We prototype on the digital auto. So I know some of you would have heard. We also have a stall outside, inside where we are talking about digital auto. So there is a playground and also a hardware POC where you could try out applications with vehicle API and OSR data points. Yeah? So this is really helpful for you to at least start. For majority of the people, although we are talking about SDV in so many spaces, none of us have really tried it out. So if you go to digital auto, they give you really brilliant examples of what all apps you could write. For example, you can write an app based on if you're going in a hilly region and if you face some kind of a kinetosis and you roll down your windows, so it will automatically roll down your windows. Kinetosis is some kind of a dizzying feeling if you're going in a mountainous path. Yeah? So there is so much unexplored potential in writing all these apps. The ideas also have not come out. For example, nobody thought WhatsApp would come out of Android. So once the platform is there, so the apps would start coming up. So some of these examples are already there in digital auto, and I really encourage you to go look at that. And we try to prototype all of our work with vehicle API on digital auto. And these apps could be directly flashed onto this POC hardware. And what you have here is basically a simple representation of architecture on this is the hardware. And this has this app management and the data broker which I spoke about. And this UDC feeder is basically the CAN signals which are being converted into OSI data points by this data broker. Yeah? And the app, so the app is here. The app reads it. Yeah? From this app management on the actual hardware. Yeah? So this is showing how you flash it onto the actual hardware on the cloud. So actually, in the playground, you can write the code and you can flash it onto this hardware, which is the stream kit. Yeah? And the stream kit is there on the next room. Many of you would have just gone to this project to see this device where you could see actual code being flashed onto it. You can open your laptop, go to digital auto, write some code, and you can flash it off this, and this would work. So this has both AUTOSAR Classic as well as RTU running. Yeah. So that is the background for this. And certain things about the dream kit, it has this, the hardware is basically a processor. It is an XP-S32G2. It's the gold box. It has both classic microcontroller as well as processor inside. Yeah, so it makes perfect sense to use this as an initial POC to try out a lot of things. Yeah? So we built our tool ecosystem around this dream kit, so at least to start working on SDV topics. So this is the major part of our experimentation with AUTOSAR as well as OSR, and it has been a quite rewarding experience to know. Yes. So what we learn out of this is this. Yeah? There's a lot of things which are different in different ecosystems, but there's no single Swiss knife tooling which in a changing SDV environment. So every year you would see new things in the SDV. So you don't have a single purpose Swiss knife for this. You really need to make things interoperable based on certain things which are constant. And what is constant really are APIs and data models and the model-based system engineering, which is not going to go away. So this part is the classic ARXML, RTOP models, which we have worked with, ARXML models. So this from the classic side is not going to go away. So we agree, we have to take it into account. But on the other side, there is a contract. On the cloud side, you have, as I said, there is a code-centric view. For those code-centric view, you have API contracts. Yeah? So we need to come onto that too. Yeah? And they need to work with our data models, which can be Cohesor VSS. And it has been very promising to put data as a data platform onto Cohesor VSS and make it work with the APIs and the classic models to build a tool ecosystem for SDV. Yeah? So these things may be constant, but many technologies around them may keep changing. So this is what we have learned over this past couple of months in doing this, and with this I would like to conclude my talk. Yeah. Thank you.